Hello. Now we are going to look at different types of numbers, some that we already know and some that might be new to us. We'll start off with our most basic kind of numbers that we've been dealing with since primary school, which is natural numbers. So these would be our counting numbers, all of our positive whole numbers. So an example of a natural number, well, the smallest one would be the number 1, or we could have the number 376. Both of them would be natural numbers. They're positive whole numbers. The next group that we would have dealt with in numbers would be integers, and they have a letter representing them Z, and they're all positive and negative whole numbers and 0. And what might immediately jump out at us is that the integers group, this definition of our group of numbers, would actually include natural numbers. If we look here, we have integers covers all of the positive whole numbers, but it also includes the negative whole numbers and 0. And this will be a theme going down our column here. All of these groups are going to be groups within groups, or subsets, using maths language. So some examples of integers might be the number -3 or 0, but the number 5 would also be an integer, and the number 376 would be an integer. So we have the negative whole numbers, 0, and also all of the positive whole numbers that we have in the natural numbers group. Going on from there, we have rational numbers. So these are numbers that can be written as fractions with whole numbers top and bottom. So something like 4/5 would be a rational number. That's a whole number divided by a whole number. This is the formal definition where you have a over b, where a and b are integers, but b can't be equal to 0. We can't divide by 0. This is the formal definition, but this is what that formal definition means in English. But just like with our integers, if we think about what we know about whole numbers, they're fractions too. We don't normally bother writing it, but -3 means -3 over 1. So any of the integers or any of the natural numbers would also be examples of rational numbers. So -3 over 1 would be a rational number as well. They're both whole numbers, top and bottom of our fraction. Or we could have 7 all over 24. Any fraction that we have that is whole numbered top and bottom is fine. And that must include all of our whole numbers as well, because that means that we just have a denominator of 1, a bottom number of 1. So our 376 all over 1. So that's our natural numbers, integers, and rational numbers. Now we can also have irrational numbers. So irrational numbers just means not rational numbers. Well, if a rational number is something that can be written as a whole number fraction, then an irrational number is something that can't be written as a whole number fraction top and bottom. So we can't have a whole number divided by a whole number. So where would we get examples of that? Well, where we've dealt with them before would be numbers like the square root of 2 or the square root of 7. Our surds are square root numbers that don't work out nicely. So some square root numbers will work out quite nicely, like the square root of 81 is just 9. Well, that's a whole number, so that would be fine. That would be rational. But if we try and put root 2 or root 7 into our calculator, we're not going to get out a nice result. It's a decimal that keeps on going forever, and we're not able to write it as a nice fraction. We've also dealt with numbers like pi when we deal with the area of a circle or the circumference of a circle. And we may have also dealt with numbers like e when we be dealing with powers of numbers. So there are some numbers that we can't write as fractions, and because fraction numbers are called rational numbers, non-fraction numbers are called irrational numbers because they can't be written as fractions. Now, all of these together are inside the group called real numbers. So all of the numbers that we have dealt with so far in our mathematical work are real numbers. So natural numbers, integers, rationals, and irrationals are all examples of real numbers. It's the big group that all of them sit within, and its letter is OR, and any of the numbers that we've picked so far, or any of the other real numbers, would be perfectly fine. So 1 is a real number, 0 is a real number, root 2 is a real number, pi is a real number. What's another example? We have 4 over 5 is a real number. I'm deliberately picking ones we already took, but there's any number that we can think of is a real number in terms of the numbers we've already dealt with. Now the new group for today is complex numbers. Now technically all of the numbers we've been dealing with have been complex numbers, but we didn't know it. And we'll come to complex numbers in a lot more detail soon. But complex numbers are numbers that have what we call an imaginary part. They're a part that has a letter in it called I. And while I acts like a normal variable, it acts like an x or a y in some cases, it actually has a very specific meaning. I means the square root of -1. So when we would have done work with solving quadratic equations and we got a negative number underneath our square roots, that's where complex numbers would come in. So now we're going to learn how to deal with situations where we get a minus number underneath a square root. And that's going to give us imaginary numbers. And those numbers have to be written in a special way. This is a form of writing a vector. And it's where the real part plus the imaginary part is written out. So an example of that would be a number like 7 plus 5i. We'll look at these in more detail later, but if we ever see a number that has the letter I in it, we know that it has to be a complex number. So we'll go on and now have a look at which of these numbers down here is going to be a rational number. So a number that could be written as a fraction. We're going to simplify these numbers if we have to in order to be able to see them. So if we're asked a question like this in an exam, we're going to see if we can simplify our numbers before we make a judgment as to which one of our groups it would be best to say that they were in. So the square root of 636, well, that looks like a square root number, so it could be irrational, but I could put that into my calculator and I would get that that's actually just the number 6. Well, that's a whole number. It's a positive whole number, so we could say it's a natural number, but we know that all natural numbers are rational numbers because this is the same as 6 over 1. So that would be a rational number. It can be written as a fraction of whole number divided by whole number. -8 all over 7, well, the fact that it's a negative doesn't really cause us any problems. It can be written as a whole number divided by a whole number, so that's a rational number. 2.6, can that be written as a rational number? Well, it's not a whole number at the moment, so like 2.6 all over 1 would not meet our rule for a rational number. It's not a whole number divided by a whole number. But could we simplify it to make it look like a rational number? Well, 2.6 would be the same as 2 plus 6 tenths. We know that after the decimal point would be tenths, so this is 6 tenths. So could I add these two things together and get just a normal fraction, a whole number over a whole number? So what I could do is say that 2 is the same as 2 all over 1 would be the same as 20 all over 10. So I'd have 20 all over 10 plus 6 all over 10. I can write that in, just showing my work, and then I'd have 26 all over 10. Well, that is a rational number. Normally though, we'd want to simplify our fractions. So we have a common factor of 2, so we would end up with 13 all over 5. Again, we could divide above and below by 5. So that one would work. That is a rational number. I can write it as a whole number over a whole number. If I have root 2, if I try and put that into my calculator, I don't get out a decimal that stops, so I can't write that. That would be an irrational number. I can't write it as a fraction. 0 is fine. It would just be 0 all over 1. That works. pi, if I try and put it in my calculator, I can't write that as a whole number over a whole number, so that doesn't work. It's irrational. 3 plus 8i, I see an I there and I say, well, I can't have an I in here, so that would be an outer group that's not going to include my fractions, so that isn't going to work as a rational number. Here I see I have a square root over something, so I need to put that into my calculator. Square root of 81 is 9, square root of 25 is 5, so that works. That's a whole number over a whole number. The square root of minus 1, we've learned we call that I, and if we see an I, that means a complex number, so that doesn't work as a rational number. And here we have minus 1.9, that's going to be the same as minus 1 minus 9 all over 10, and I can rewrite that as minus 10 over 10, and that works out. I get minus 19 over 10, that's whole number over whole number. So could I fill in this diagram here? I talked about the fact that our groups that we're talking about are effectively subsets of each other. This is a Venn diagram of all of our different groups that we have talked about. So where could we fill in our different numbers? Well, 6 would just be in the whole number of our natural numbers group. Minus 8 all over 7 would be in the rational numbers group. You can write it as a fraction. 2.6 would be in the rational numbers group. And root 2 would be an irrational number, so it is in the real numbers but not in the rational numbers. And then 0 is an integer. Pi is an irrational number. 3 plus 8i is a complex number, so it goes all the way out there. Root 81 all over 25. A rational number. The square root of minus 1 is a complex number. And then minus 1.9 is a rational number. So that's how we could fill in our Venn diagram for where the different numbers we had there go. Now, to just reiterate on complex numbers, they're numbers involving the letter I. Now, technically, all of these numbers that we've dealt with are inside the complex numbers group, which can be a little bit difficult to think about because I said it had to have I in it, but we could have 0i, and that would still technically be a complex number. So the way we have our complex numbers written is we have a real part called A plus the imaginary part, the bit that involves I. So the real part for our first number here would be minus 6. The imaginary part would be 1. We have 1i. For the number 14, the normal number 14, you have a real part of 14. And you have an imaginary part of 0. So we could write that, and sometimes we'll have to write that as 14 plus 0i. Here we have minus a fifth I. Well, there's no obvious real part there. That means we have 0 for our real number. We'd have minus a fifth for our imaginary part. And here we have a third plus root 2i. Well, the real part, the part not involving I, is a third, and the part involving I, the imaginary part, is root 2. So this can take us a little bit of time to get used to. Our normal number 14, or our normal number 6 here, can be thought of as 6 plus 0i. So it would still be in the complex numbers group, even though we don't normally have to deal with it in that way. But we will in this chapter. So all of these numbers are inside the complex numbers group. And that is what we need for now.